Hi, hello everyone. Welcome to Secondary School Chemistry. Now, this is day three of solving random NECO questions from NECO 2026 chemistry question, the one written this year. So, this is day three of solving random question. Now, looking at the theory question, I just picked a random question and it's under exothermic reaction, it's under chemical reactions. Now, the question reads this question 3A. With the aid of an energy profile diagram illustrates the effect of catalysts on an exothermic reaction. We know catalysts affect the rate of a chemical reaction. So we are asked to use a diagram, an energy profile diagram, to show how catalysts do affect chemical reaction. And the reaction should be exothermic. Now, let's dive into this. It's a diagram and let's start. First of all, in an energy profile diagram, it has two axes here and here. This axis is the energy part. The energy part can be any level, and this other part is the reaction pathway, the flow of the reaction. In that question, we are told clearly that the reaction is an exothermic reaction. And we know exothermic reaction, the enthalpy change, the enthalpy change is negative, meaning that the energy of the reactant is higher than the energy of the product. So in an exothermic reaction, the energy of the reactant will start from a higher energy than the product. So if our reactant starts from this part and during the reaction it moves to a particular peak, it will come down to a lower part. So here is the reactant and here is the product. So the difference between these two is negative. Remember, the product minus the reactant, it gives us a negative value, then it's an exothermic reaction. So this is the product, the energy product is here, the reactant is here. So this difference will give us a negative enthalpy change. Now, the second point here is to show the effect. Now, during the chemical reaction, the enthalpy is energy that is being used in the chemical reaction. So the energy of the reactant that the reactant possesses is from here down to here. This is the activation energy. It is called the AE, activation energy. Now the peak is called the activated complex. So this is the activation energy. When we now introduce catalyst here, what will the catalyst do? The catalyst will alter the activation energy by slowing down the time. So the dotted line will show the pathway of catalyst. So when catalyst is introduced on the same energy level of the reactant, it moves creating a shorter activation energy, but the product still remains the same. So without catalyst, you can see the activation energy ranges from here to here. But when we introduce catalyst, you can see the activation energy is now shorter. So this is the activation energy of reactants. It's smaller than that of the activation energy without without catalyst. So what catalyst simply do is to shorten the activation energy. Activation energy is the energy needed by the reactant. The energy needed by the reactant in order to give us the product. So when catalyst is involved, the energy will be shortened. And when energy is shortened, the time of that reaction will also be shortened. So catalysts alter the rate of chemical reaction. So this is the sketch of the energy profile diagram of an exothermic reaction. Remember, it's an exothermic reaction because the energy of the reactant is more than the energy of the product. Now, this dotted line shows the pathway when catalyst is now involved. Hope you learned something from this energy profile diagram. See you in my next video. If you enjoy watching this video, make sure you subscribe to this page. Have a nice day and bye for now.